All right, today we're going to be doing lesson 5, which is parts of an expression. So there are 4 different parts of an expression. So we have our words up here that describe each one, the definition, and then we'll show you an example before we get started with actually finding them ourselves. So the first part of an expression are terms. Terms are parts of an expression that are separated by plus or minus signs. So if you look at this example, we have 6x plus 10 plus 8x plus y plus 4. So we only have addition in this example, so anything that's separated by an addition sign, so I have 6x, then there's an addition sign, I have 10, addition, 8x, y, and 4. So this specific example has 1, 2, 3, 4, 5 different terms. So my terms would be 6x, 10, 8x, y, and 4. The next part of an expression would be like terms. Like terms are terms that contain the same variables. And then when we talk about constants, we'll talk about how those are considered like terms as well. So in this example, we have 2 different variables. We have some x's and we have some y's. 6x is a term, and it is a like term with 8x because they both have an x in it. We'll talk about what a constant is in a minute, but just these numbers that are not attached to variables, 10 and 4, are also like terms. The reason they're like terms, and we'll talk about this in a later lesson, is because you can combine them together. The only one in this example that does not have a pair as a like term is the y. No other term has a y as a variable, so that one just stands alone. 6x and 8x are like terms, 10 and 4 are like terms. Another part of an expression is a coefficient. A coefficient is the numerical part of a term that contains a variable. So if we look at our different terms, again, we have a 6x, 10, 8x, y, and 4. We're looking for any first that have a variable attached to it. So 6x would be 1. 10 would not be 1 because there's no variable. 8x has the x and y. 4, again, would not be 1 because it doesn't have a variable attached to it. So the key word here in our definition is that it's the numerical part or the number part. So 6x is our term, but 6 is my coefficient. 8x is my term. 8 is my coefficient. Y is my term. If you notice, there's no number in front of it, but how many y's are there? There's only 1. Just like we learned with our properties, 1 times a number just equals itself, so we don't waste the time putting the 1 in front of the y, but the coefficient would be 1. Last, we have constants. Constants are our terms without a variable. So same terms in this example, 6x, 10, 8x, y, and 4. 6x we already determined has a variable. 10 does not have a variable, so that would be a constant. I'm going to highlight it actually. 10 would be a constant. 8x has a variable. Y is a variable. 4 has no variable attached, so 4 is also a constant. So as we're doing our examples, refer back to this top part of your notes. All right. So for example 1, it says identify the terms, like terms, coefficients, and constants in the expression. So we're going to start with our terms. Those are the easiest to find. Anything separated by a plus or minus sign. So I'm this time not going to circle anything. I'm just going to write them down. So I have 3x is one of my terms. Since I'm just going to be listing them, make sure you don't put the operation in there. You're putting a comma to separate them. So 3x is one of my terms, 4x is one of my terms, y is one of my terms, and 2 is one of my terms. Now we're going to look for like terms. So remember, we're looking for ones that have the same variables, or we're matching up the constants. So I have a 3x and a 4x. They both have x as their variable, so those are like terms. The way I'm going to write this 3x and 4x. So again, I'm not writing the plus sign. 3x and 4x are my like terms. There are no other y's, so that doesn't have a like term, and there's no other constants, so 2 does not have a like term. Next, we're going to look for coefficients. So coefficients can get a little bit confusing, so I want you to take out your highlighter. I'm going to highlight coefficients in blue, and then also highlight up in my example. So remember, coefficients are always attached to a variable or contain a variable. So I'm going to start by highlighting any term that has a variable. So I have 3x, 4x, and y. Now remember, I'm looking for the numerical part of those terms. So 3x, how many x's are there? We have 3. So 3 is one of my coefficients right here. For 4x, how many x's are there? There are 4. So 4 is my coefficient. And then y, there's no number in front of it or attached to it, but remember, there's one y, be the same thing as having the 1 in front of it. We just don't write it, so our other coefficient is 1. Last, we have our constants. So take out a different color highlighter. I'm going to highlight constants in pink. Constants are terms without a variable. So I've already highlighted my terms with variables, so it makes it a little bit easier to find my constant. There's only one in this situation, and it is the number 2. Okay. Moving on to example 2. I'm going to look for my terms first, anything separated by an addition or subtraction sign. So I have 3 terms, 5a, put a comma in between, 4b, and c. Now I'm looking for my like terms. In this case, I have a, I have b, and I have c. I have no like terms because none can match up with each other. So I'm going to write none. Coefficients. So I'm looking for the numerical part of the term that contains a variable. So to start out, I'm just going to highlight all of my terms that have variables. Have an a, b, and c. My coefficient is just the numerical part. So I have 5a, so 5 is my coefficient, 4b, 4 is my coefficient, and since c is standing alone, that means 1 is my coefficient. Now I'm going to look for constants. Constants are any number that's not with a variable. We've already highlighted everything with the variable. There's nothing left, which means I have no constants. One thing I want to point out, if there's no like terms or no constants, or anytime you have none of something, make sure you write out the word none. You cannot put 0 and say there are 0 constants, because that would not be the correct way to put it, because 0 is a number. So make sure you write out the word none. All right, we're going to go through 2 more examples together, and then you can do the you try. Example 3, 2x plus 10 plus 2y plus 4 plus x. My terms, anything separated by my addition sign, so I have 2x, 10, 2y, 4, and x. Like terms are anything that have the same variable or constants. So I have 2 terms with x, so I have 2x and x. And in this example, I also have 2 constants. So I'm going to put a comma to separate that. I'm now going to list another pair of like terms. 10, and 4. Okay, coefficients are next, so I'm going to highlight that again. Remember, coefficients contain a variable, so I'm going to highlight all of my terms with variables, 2x, 2y, and x. The coefficient is the numerical part, so I have 2, I have 2 again, so I have to list 2 twice, and then 1. Okay, so I have 3 coefficients. Next, we're going to look for our constants. Remember, anything that does not have a variable. We've already highlighted our terms that have variables, so I'm going to highlight what's left, 10 and 4. Those are my 2 constants. Example 4, my terms, 20a, 15b, 14b, 5a, and 9. Like terms, I'm looking for anything that has the same variable. So I have 20a, and I also have 5a. So 20a and 5a are like terms. I have 15b and b. And then I also have 14 and 9, since they are both constants. They are like terms. Coefficients contain a variable, so I'm going to highlight all of my terms with variables, 20a, 15b, b, and 5a. We're looking just for our numerical part. So I have 20, I have 15, I have 1, and I have 5. Last, constants. They do not contain a variable, so I'm going to highlight my terms that are left, which are 14 and 9. And then we are all done with example 4. So go ahead and do the U-try, and then come back and get a teacher signature.